The distance between the Earth and the Sun, known as the astronomical unit, has been a fascinating topic of study for astronomers for centuries. Measuring this distance accurately was essential for understanding the vast scale of the solar system and for making further astronomical observations. The history of measuring the Earth to Sun distance is a story of scientific progress, experimentation, and collaboration that spans for centuries. One of the earliest attempts to measure the Earth to Sun distance was made by ancient Greek astronomer Aristarchus of Samos in 3rd century BC. He used the concept of trigonometry to calculate the distance of Sun based on the angle between Sun and Moon during a lunar eclipse. Although his method was innovative, it was not precise enough to accurately measure the Earth to Sun distance. In the 17th century, German astronomer Johannes Kepler devised a method to estimate the distance between distance to the Sun based on the ratio of the distances between Earth and Mars at their closest points. This approach was used by other astronomers in the following centuries to refine their calculations of Earth to Sun distance. However, it still suffered from limitations due to inaccuracies in the measurements of the planetary positions. It was not until the 18th century that a more accurate method was developed by French astronomer Jean-Dominique Cassini. Cassini observed the Mars from Paris, whilst his colleague observed it from French Guiana in South America. They were able to measure its parallax and hence the Earth to Mars distance. Using Kepler's third law, they were able to calculate the Earth's distance from the Sun and derived a value of 140 million kilometers. This approach was improved by English astronomer James Cook, who made observations of transits of Venus from Tahiti in 1769. In the 19th century, advances in technology allowed for even more precise measurements of the Earth to Sun distance. The German astronomer Friedrich Bessel used a method called heliometer measurements to make precise observations of the positions of stars near Sun. He then used these measurements to calculate the Earth to Sun distance with a greater accuracy than ever before. A truly accurate measurements had to wait until 1962, when powerful radars using large radio telescopes in USA, Russia and at Jordan Bank in UK were able to obtain echoes from the surface of Venus. The accepted value now is 140,597,870.691 km, just little less than 150 million km or 93 million miles. In the modern era, the space exploration has allowed for even more precise measurements of the Earth to Sun distance. In the 1960s and 70s, NASA sent a series of probes in the inner solar system, including the Mariner and the Pioneer missions, which made direct measurements of the Earth to Sun distance using radar. These measurements allowed more precise calculations of the astronomical unit to date. In recent years, European Space Agency's Giga mission has continued to refine our understanding of the Earth to Sun distance. Giga uses advanced astronomical techniques to make precise measurements of the positions and the motions of the stars, which can be used to calculate the distance to the Sun with an incredible accuracy. In conclusion, the history of measuring Earth to Sun distance is a fascinating tale of scientific progress, experimentation and collaboration. From the ancient Greek astronomers to modern-day space missions, astronomers have used a variety of methods to refine our understanding of the astronomical unit. Each measurement has helped to expand our knowledge of the vast scale of our solar system and the universe beyond. So thank you for watching this video. We hope that you found this information informative and helpful. If you have any questions or comments, please feel free to leave them down below. Don't forget to like and subscribe to our channel for more videos like this. And also don't hesitate to share this video with your friends and family who might find it interesting. Thanks for tuning in, and we'll see you in the next video.